Okay, I hope you've had a great week, my sweet classes. Today I'm going to teach lesson 37, which is adding and subtracting rational expressions. By now you should have already got your notes ready to work. This is a kind of a review from Algebra 1, and it goes with adding like fractions and with common denominators and unlike denominators. So for example number 1, go ahead and write down 1 plus 2x, 1 over 2x plus 3 over 2x. Now, if you remember from adding fractions, in order for us to add fractions, we have to have the same denominator. And in this case, in example number 1, we do. So when we have that, just like regular fractions, we keep the same denominator. So I would have 2x. And so then we add our numerators, which is 1 plus 3 is 4. So that's going to give us 4 over 2x. Now, if we look at that fraction, we can reduce that. So my answer is 2 over x. And if you notice, we have a variable on the bottom, so therefore x cannot equal 0. In this case, I do not want you to give me any undefined values until the very end. Okay, for example number 2, go ahead and copy down x over x squared minus 2x plus 1 minus 1 over x squared minus 2x plus 1. Now, if you notice, we have the same denominators, so we're going to go ahead and bring that over. So I have x squared minus 2x plus 1. All right, and then I'm going to add my numerators, or subtract them in this case. So x minus 1 is x minus 1. Now, if you look at our denominator right here, okay, x squared minus 2x plus 1, I'm going to see if we can factor that. And I have x minus 1 over, and what two numbers can I multiply together that's going to give me a positive 1, but when I add or subtract them, I get negative 2. And it's negative 1, so I have x minus 1 times x minus 1. Now, if you look at what we have now, is there anything on the top that will cancel with anything on the bottom? And yes, there is. So I'm going to cancel those out. So because I've canceled everything on the top, that leaves me a 1 over x minus 1. And that's my answer. However, I also need to look at the denominator. I have an x on the bottom, so x cannot equal what? 1. That is correct. Okay, example number 3. We're going back to 5th grade when we add fractions with unlike denominators. So for example number 3, go ahead and write down 2/5 plus 2/3. Now, I do not want you to work ahead. I want us to do this together so that it brings everybody to the same page. When we have a common denominator, or unlike denominators, we find something in common that both denominators have, which in this case is 15. So we put 15 and 15, and then our heads, what we do is we say 5 will go into 15 3 times, and then with that 3, we multiply it by the numerator. So 3 times 2 is 6. And then we do the same thing with the second fraction. I have 3 will go into 15 5 times. 5 times 2 is 10. And then from here, we add like terms. So 6 plus 10 is 16 over 15. And that's how we get our answer. Okay? Now, with example number 4. If I have, let's go ahead and add 1 over x squared minus 4 plus 1 over x squared, plus 5x. Oops, this is getting ugly. Hold on. You have x squared minus 5x plus 6. All right, now, in order for us to see if we have a common denominator, the first thing I want you to do is I need you to factor. So on that first fraction, x squared minus 4 is x minus 2 times x plus 2 plus 1 over. That trinomial factored out is x minus 3 times x minus 2. Now, I'm going to refer back up here to this problem, example number 3. Now, in order for us to find a common denominator between 5 and 3, there was no number that 5 and 3 will go into unless we multiplied them together. The same case goes for binomials and trinomials, okay? I do not have anything in common. The only thing I have in common is x minus 2 in both fractions. So I have to use all of that for my common denominator. So my common denominator, let me just, my common denominator is going to be x minus 2, x plus 2, and x minus 3. That's my common denominator. So in my head, I'm going to put that whole thing, x minus 2 times x plus 2 times x minus 3. Okay? Now, let you get caught up. So from here, remember, just like up here where it was 15, what we did was we multiplied 5, or we canceled 5 into 15 3 times, and then we multiplied back. So x minus 2 and x plus 2 is on here, so that only leaves x minus 3 to multiply with this 1. So that gives me x minus 3. Then on the second fraction, I have x minus 3 and x minus 2, which will give me x plus 2 to multiply with the 1. Now I look at my numerators. Do I have like terms? The answer is yes. So I have x minus 1 over x minus 2 times x plus 2 times x minus 3. There's my answer. And then do not forget that x cannot equal negative 2, 2, and 3. Okay, for example number 5, go ahead and copy down 1 over 3x cubed plus 1 over 6x squared. Now we're adding fractions with monomials, so this one's going to be pretty easy. My first step is I'm going to look at my coefficients, which are 3 and 6. What number can both 3 and 6 go into? And the answer is 6. Then I'm going to look at my letters, okay? And you have to remember, what can both of the terms go into? Well, x cubed can go into itself one time. X squared can also go into x cubed. So I'm going to be using x cubed. So in other words, you want the one that has the highest exponent. So now, there's my common denominator. So since we can't do these in our head yet, we're going to write it up top to help us out. And just like in example number 3, 3 will go into 6 2 times, and x cubed will cancel. So all I have to multiply back is 2 times 1, which is 2. Sorry for my ugly handwriting. Let me try to make that pretty for you. There you go. Now, 6x squared will go into 6x cubed. All of that leaving 1x left over. So 1 times x is x. So now I add what I have up top, 2 plus x over 6x cubed. And I can't factor anything, so therefore nothing will cancel. So this is my answer. I have x on the bottom, so x cannot equal 0. Okay? Example number 6. We'll go ahead and put this up here. We have 1 over x squared minus 1 minus 1 over x squared plus 3x, sorry, it's an ugly 3, plus 2. Now, in order for us to add these, or in this case subtract them, we need to do what first? Exactly, factor. So I have x plus 1 times x minus 1. And then I have x plus 2 times x plus 1. So my common denominator, remember, if it's different, I got to use it. So I have 2 x plus 1s, so I can go ahead and put x plus 1. I have an x minus 1, and I have an x plus 2. So I have to use all of those. So if it's written on the bottom, and it's a binomial, and it's different, I have to use it. Hope that makes sense. All right, if it doesn't, just ask me on Monday. Okay, with that being said, if you want to write the denominator up top, x plus 1 times x minus 1 times x plus 2, all up top. Excuse my ugly handwriting. Now remember, if it's on the bottom, it will cancel out up top. So I'm looking at these right here. X plus 1 and x minus 1 is on the bottom of this fraction. So that only leaves me x plus 2. So I'm going to multiply x plus 2 times 1, which is x plus 2. Now in the second fraction, I'm looking at x plus 2 and x plus 1. They're on the bottom, so that only leaves me x minus 1 up top. Now, I'm going to combine this, but I need you to look really carefully at this sign right here. I'm subtracting this whole numerator. So whenever I subtract the whole numerator and it's a binomial, what property am I going to need to use? That's right, distributive property. So in my numerator, I have x plus 2 minus x plus 1 over x plus 1 times x minus 1 times x plus 2. Now look at my numerator. What happens to my x's? They cancel, leaving me 2 plus 1 is 3. So I have x plus 1 times x minus 1 times x plus 2. And there's my answer. And I need to also put that x cannot equal negative 1, 1, and negative 2. And I'm done. All right, I hope that these were plenty of examples. If not, we'll review this on Monday, and we'll go from there. Be ready for your quiz on Tuesday. Have a great day.